Hello, everyone, and thanks for being here. Um, Many of you know me for uh, the stupid things I do with on-chain games and also abusing various rollups with like a bunch of transactions. Um, but today I want to talk about something different, and this is actually something that came a little bit of like a spur of the moment thing. Um, Bora, the Celestia team knows very well that I just finished my slides like 1 hour ago because I just like redid everything. Apologies for that, but hopefully it will be worth it. Back in my college days, which is not a long time ago, I have like one friend, his name is Linus Lee, who wrote a blog post called Build Tools Around Workflows, Not Workflows Around Tools. Um, and this one blog post at first feels, for someone who've never really taught it, feels like a bit esoteric, right? Like, why would you, in a world where you have startups with millions of dollars in funding building your software for you or building your tools for you, would you want to build something yourself that you might not even be half good at, right? But turns out this blog post changed the way that I think about software and how I think about designing tools for many, many years after and still on until now. One of like Lysis' main argument is that each person's mind works a little bit differently than each other. Everyone is doing something a little bit different. Some people, even as a software engineer, we're working on very, very different products. We're working in a very, very different companies, different teams. Our day-to-day looks very different. The way that we were raised and educated is extremely different. And every tools that we're using today are designed for the average. It's designed to cover the maximum amount of use case possible um, to basically accommodate for these different various use cases that people imagine in the world. And if your workflow just doesn't seem to fit these use cases or the way that the world have thought about like how like no certain maybe CRM or whatever works, then you suddenly have to contort your mind to work with these tools. And this is a little bit annoying, right? Because your mind works the best when you're in your zone of genius, when you have this symbiotic relationship with tools that you use. And you kind of reach that eureka moment, that aha moment, when you're even the smallest software that you use, like your to-do list, your notes, your calendar, works that the way that fits your brain. And when we resort to using tools that other people like, give to us and using blockchains that other people just like, hey, without including you in a conversation, say that this is how you're going to build your applications, this is like how you're going to build your games, then you're restricting the things that like your team is like using as a creative outlet, right? Your medium, your canvas is limited by those constraints of assumption that other people make about how your mind works and like what you want to build. And every time I think about, every time I think about these tools, and every time that I think about, um, this symbiotic relationship between a man and their software, I've always like pictured this scene from like Iron Man 1, where like Tony Stark and like Jarvis is like working together to build the first Iron Man suit. And isn't it just like amazing when you just like have a software that fully understands you and gives you the space to do everything you need without you having to go on Google Workspace, log in, and then you hop onto Notion, and then your Notion connects to Obsidian, and so on and so forth. And that feeling is the feeling that I want to have when I'm building software. And I encourage you to kind of really take a pause, right? Don't think about rollups, don't think about blockchains, don't think about anything that you've known until now. Like, remove all preconceived notions that you have about software. And just imagine a future or imagine a reality where your apps integrate seamlessly and you control over what apps can do with your data, in a world where your data is fully in your control and always available, and when you get to build a system that works for you instead of a mangled Frankenstein monster. This is what a rollup is. This is the promise that rollup gives to the world, right? Instead of having these like monolith, mainframe computer that tells everyone, hey, if you want to use our computer, check in for like these like 1 hour cycle and like take turns with other people in terms of how you want to use computer. Rollups says that, hey, you can just make your own. You can just spin up your own environment, have your own creative space, and create an environment that works for yourself. instead of having to conform to these like different dimensions of optimization that simply isn't relevant to you, um, or your users or your use cases, and etc. And a lot of this really comes like from these like seemingly slow but pervasive gaslighting in terms of like what a rollup is and what a rollup can do. The reality here is you have been lied to. Rollups, like we say that these days that rollups are, again, hard to run. You don't have no reasons for you to have your own rollup. Or, the alignment anons would tell you like, hey, yeah, why do we have another rollup companies that raise $50 million? And there's this constant stream of barrage about how like, again, all we needed is like this like one rollup or like et cetera, right? This is like the narrative that constantly pervades like the narrative of the space, right? And again, some of them have a little bit of truth, which we'll be covering later. And like, but just remember that this is like simply the existing constraints that we have. These are not things that are inherent. There's nothing about this that is inherent to the way that a rollup are designed or like rollup or data availability architecture has today. And you can kind of just really kind of picture yourself right now living in a world where like, you have this like boomer guy working for these like very large like company just telling you that there's a world and like market for maybe like 5 rollups, right? And like, the original quote here was like, I think Thomas J. Watson, who's like the chairman and CEO of IBM back then, was saying like, oh, there's only like a market for maybe like 5 computers, right? And if you think about this today, like you kind of like realize how insane it is, right? Like how the statement is insane. When everyone has like computer within their pocket that is like orders of magnitudes faster than the computers that we used to have, in the 1900s. And this just like speaks volume in terms of like how like we just like don't have a good understanding of like where scale can go and how ubiquitous the softwares that we currently that currently is only accessible for businesses and large teams can be for many people all around the globe. And there's also this other quote from this like other very real guy that I think like one of the greatest mistake that we can make as an industry is like if we let the alignment anon wins and like just like say that like we don't need any more rollup, we should stop building rollups. And then like let us enter into this like roll-up dark ages where everyone just give up, like everyone just stop bothering, thinking about roll-ups and pushing the way and getting roll-ups to as the hands of as many people as possible. And like that would be a very sad world to live. And again, the problem here is like very simple, right? The roll-ups and its lore today are written and made by IBM-like people for IBM-enjoying people, right? You see these people who are like building new roll-ups simply for the sake of like, okay, we just need to protect our distribution. We want to like basically capture our own value, want to extract the maximum value possible from our transactions, and therefore we want to have a roll-up. So these are like very, very zero-sum like mindset where the intent of the roll-up is less about having capabilities and having a creative canvas for yourself and more so about value capture, which I think is misdirected. And again, it also leads from this like very skeuomorphic design philosophy that we've always had over rollups that has this like formulaic pattern of like, it's like just EVM, SVM, or MoveVM, but we post the data to untitled data availability layer and it goes fast. And then you raise $69 million in funding, but still can't hire anyone with imagination or soul inside. And the reason why these all started in the first place was because rollups at its first inception was created to solve the scaling problem of the L1. And the L1 was just simply, okay, like let's just do the same thing, but like on a layer n+1. And that is like why all of these rollups are skeuomorphic with each other. And one of the things that you'll notice with any like L1s is that almost all of them is designed with what we like to call a multi-tenant virtual machine, right? And the reason for this is simple. Like having a single tenant virtual machine or compute layer means that you would have to bootstrap consensus every time you're like, you need to create a new chain. Every time you want to like build a new like feature, you want to add a new functionalities, like add more like user-generated content that is created by the user. And partitioning them into a smaller chain is going to be prohibitively expensive. With that said, rollups don't have this problem. Like the whole reason why I think people should be building rollups instead of one is that you can do it quickly. There's like very low overhead costs. It's like very low commitment. Um, and you can actually just like spin up smaller rollups and like be done with it like much easier. You don't have to align and work with validators to just like get your chain validated up and running. You can at the comfort of your home run your own sequencers. You can run your own chain without having to worry about these like whole coordination games and social incentives. That is the beauty of a rollup, and like just how simple it is for people to get started. And the last but not least here is like the reason why rollups are so hard is not simply because rollups are, again, like the marginal cost of computing is expensive. It's not because like AWS is expensive. It's also not because like data availability is expensive anymore. You can like create a rollup that poses a shit ton of data to Celestia right now and barely have a dent in your pocket. Like, data availability is extremely cheap right now. The reason why costs are so expensive, if you like get like an invoice from like one of these rollup as a service provider, is like, literally just on like these like fees for running hardware for full node RPC, for running like sequencer nodes, having it to run DA nodes, and so on and so forth. And with 48 cores and 256 gigabyte of RAM, with a node software written in Rust that only like PhD students can read, it's like hyper parallelized and all of that, you still have the same performance as like a WordPress blog. And like at that point, like what's the point, right? Like, it's just like simply not efficient enough for the kind of like for rollups to make sense to have to be owned by like every individual users. Instead, you kind of have to deal with like, okay, like yeah, the rollups are so big, it supports like like all of these like different smart contracts and all these different users, but at the end of the day, not everyone can have a rollup. We all are just like renter or just like with this like landlords of like the like L2 or the L1 hegemony. Again, words dream up by the utterly deranged. I'm sorry. And all of this makes me sad because my dream is to have a rollup on every desk. Um, and again, some of you might think like, oh, this is like far-fetched. Why would we want to have a roll-up on every desk? Well, to a certain extent, yes, it is a little bit kind of extreme. It's a bit hyperbolic. But we encourage you to use your imagination when roll-ups are so cheap that everyone could be running one on your desk. Mind you, this is not full nodes. These are not Bitcoin full nodes. These are not like read-only nodes. These are actual compute that is like actually processing transactions and like processing like state updates on your desk. And how are we going to get there, right? The answer is simple, right? The common user, the common like everyday Joe, simply do not have the brain prowess, do not have the DevOps team, do not have the Kubernetes expertise to maintain these like large clusters of RPC nodes and build these like multi-container architecture and to like make sure the your sequencer is working, the DA nodes are working, and so on and so forth. So we want to make sure that we're building a rollup that is so simple, so foolproof, yet give you all the performance that you need to do whatever the fuck you want. And so step one for us to be able to do this is to push what's possible. Blockchains are slow, rollups are slow, and so we need to fix that first. And literally in New York, 2 years ago, we launched the first version of the World Engine. And the World Engine was an ambitious vision to make rollups horizontally scalable. Previously rollups were only able to, support this like fixed amount of transactions, and after that you can't process anymore. We built like in my past life, I co-created a game called Dark Forest, where people would just like fill up the entire block space of like the chain, and no one else can use it, and they're like, we can't even accept more users to our game. And this became a problem very quickly, and that's why we created the World Engine. The World Engine comes with a novel architecture for rollups that we call execution sharding that allows you to add up new shards to process more computes while isolating those computes against each other so that you don't have a busy neighbor problem, and various other low-level implementation details that I will not bore you today. And then last year, just on Modular Summit, we beat the speed of light. Previously, rollups have problems with high latency. You would have to travel all across the globe to just be able to get your transactions processed. Your games and your use cases are limited to like slow-moving like games or like slow-moving applications. Every time you send a transaction, you would take like almost like 1 second of round trip time. Like you would have to wait for your transaction to get processed before anything that you see in the game gets rendered. So imagine if you were playing, let's say like Smash. Like I know like Zon and me have a business to settle here with Smash. Um, Imagine every time you press a button, the button only gets like reflected on the screen like 1 second later. That is the problem that we had with rollups, and we as a game company had to build and work around this to create a way that we can like reduce this latency as quickly as possible by eliminating the current redundant infrastructure like indexers and like Node RPC and so on and so forth, and allowing game clients to interact directly with the game shard sequencer. And we've built really, really amazing things with like World Engine V1. We launched Dark Frontier, which is our own game, and we had a lot of fun with it. A lot of people had a lot of fun with it. We were able to process like hundreds of thousands of transactions within the 1 week that we were in Dark Frontier. And that has been like a very educative experience for us. Previously, we were running like clusters of like Node RPCs with gigabyte, like 64 gigabytes of like dedicated servers, just like trying to back one Dark Force instance. With the launch of Dark Frontier and the World Engine, we only pre-allocated 2 gigabytes of RAM for the game shard of Dark Frontier. And this becomes like one of the lowest footprint blockchain to be able to run these like level of compute without having to burn through your whole these like other giant sequencer nodes roll-up frameworks. Afterwards, we also make sure that we are able to get cool people to build cooler games like we were able to do. And I'm super glad and super happy to see that Hakashi, like one of our third-party developer team, were able to create a game on the World Engine during Mamathon, which won like a prize during the Celestia hackathon, which is like super cool. And if you're interested, definitely check them out. And last but not least, and I think like this is like a bit of alpha leak, is we are working on a game called Rampage, which is going to be our next generation of fully on-chain games that is going to abuse the living shit out of our rollups. And in Rampage, every player, mind you, every player will send 20 transactions per second. This is not going to be one of those like cookie clicker clone game. These are going to be real-time games with players moving around the map in real time. And picture this, right? 100 players of like Rampage will generate 2,000 transactions per second. And again, these numbers doesn't really make any sense without context. And so I think like some numbers in context would be nice in order. Like the current blockchain in the rollup ecosystem with the highest number of throughput is Base with 100 user operations per second, but we can just call that transaction per second as well. So the things that we're building today are on a much more like larger magnitude of performance requirements and scale than anything that exists right now, but yet with a smaller footprint and easier maintainability than what is currently presented with the existing rollup architecture. And now, the second step here now, we've built something so fast, and like in the past year, we've spent a lot of time thinking about how do we get this for everyone, right? Because the reality here is like, I don't see any one of you running on your own rollups in your desk, right? So like, how do we get here to there? And so when we were designing the second version of V2 of World Engine, we asked our development team 2 questions, right? How can we make it brain that simple, cheap, and operate a rollup for everyone? These days, a lot of these complexities are not gone. These complexities are simply abstracted away to rollup as a service provider. But under the hood, running a rollups are still very, very hard. The amount of nightmares and like incident response you have to deal with as like a rollup as a service provider is immense, because running a rollups is simply very, very complicated. And the second question that we ask ourselves is how do we get this technology to the hands of everyone, right? How do we make it cheap enough that people could just like lift a rollup on, like in their instance or like their compute layer without, like sweating, giving a sweat about like the compute costs they're going to have to pay to run these rollups. And so to kind of look for a solution for this, we give a quick, pause to ourselves to look into like one of the most like arguably, I'm a bit of a nerd, is one of the greatest software architecture in the world, which is like the Linux kernel or the Linux operating system. And one of the most interesting thing about the Linux operating system is that the separation between the user space and the kernel space. And by separating this kernel space from the user space, the users are able to compartmentalize their application layer with the actual like bare bone infrastructure that is needed to run the computer. And by doing this, you can have multiple virtualized like user space, and then you're gonna have containers, and then like all of them would share the same kernel space without having to have all of these redundancies. And so this is like where the execution sharding shines again. Before, in a smart contract blockchains, your applications need to conform to the constraint of the smart contract virtual machine. And if you want to have make any changes to this, then you would have to launch a completely new different rollup. And you would need to launch a completely new different chain that changes these like fundamental like parameters of the smart contract virtual machine. This is what happens when your user space and kernel space is combined into like one layer. In the World Engine, using execution sharding, we're able to compartmentalize the user space and the kernel space. Well, so like that gives us the benefit of being able to run these like supporting infrastructure, like sequencers, like node sync, posting data to the data availability layer, like write ahead log, and so on and so forth, into one single like shared layer. Well, the execution itself is given fully completely independent and full control to its own users. And by doing this, we can allow users to, again, some rollups just doesn't have enough users. Some rollups might only have like one transaction per day. We want to make it possible for those rollups to exist. Previously, it just doesn't make sense for a rollup to have only one transaction per day. But now, because we're able to amortize this cost, all of this becomes accessible, and people are able to build rollups for themselves. And so this is like what the World Engine is today. The World Engine is building a rollup framework that is so fast that you don't have to worry about whether it can be on-chain. From high-performance real-time games to something as simple as an on-chain blogging platform, right? Imagine like being able to say that your block is immortalized in the Celestia blockchain. That's like something that you can do as easy as writing your own like shards in the World Engine stack. And again, we want to make running a rollup as low commitment as possible. Right now, when you launch your rollup, you have these like looming expectations from the community that you will have to maintain your rollup forever. But this is, I think, an outdated way of thinking about rollups, right? When we launch a SaaS service of a software in a cloud, we've never make promises that hey, this like cloud is or like these applications is gonna run in this backend forever, and we want to make sure that like you can do that with rollups as well. And the way that we again are able to do this is by separating the shared kernel space where you're storing your asset ledger into a shared shard while kind of having your own execution shard maintained for yourself. And so when you pull the plug, when you say that, hey, I'm bored and I don't want to run this rollup anymore, you can just do that. You don't have to worry about like telling your users having to migrate off your tokens. You don't have to get the users to like remove the fees or whatsoever. And you can just like you know what? We'll move on to the next great things and like continue from there. Again, all of this for 25 a month in compute costs at the minimum, with zero operations headache, to you. And again, to conclude all of this is, I think there's three things that I want to get across. In that in the not so distant future, everyone's going to have a rollup, not just large businesses. And yes, this includes you and me that just want to have a new personal block that you can brag about to your friends. Rollups are going to look very much different, like much smaller, much faster, much easier to maintain. And last but not least, rollups are going to be so fast that counting transactions per second is going to be as silly as measuring the requests per second on your personal block. And again, all you have to do now is to forget everything that you know about rollups, because things are going to be very different. And again, if this is all excites you and you want to talk about your use case or just want to get nerd snipe on rollups, feel free to reach out on Twitter or Telegram. My username is sfsonario everywhere. And yeah, that's pretty much it. Thank you.